Di Indonesia ada Solo hingga Rio. Di Brasil ada Sao Paulo hingga Rio de Janeiro. Senang sekali saya bisa membawakan acara podcast bersama IMIP yang menghadirkan para pakar yang ahli di bidangnya dan mempunyai banyak sekali pengalaman dalam menekuni bidang itu. Kali ini saya bertamu di negeri Brasil, menemui salah seorang profesor yang ahli di bidang nanoteknologi, yaitu Profesor Paulo de Souza. Profesor Paulo ini mengatakan kepada saya dalam perbincangan singkat bahwa nanoteknologi ini sangat berperan penting dalam menangani isu-isu climate change. Salah satunya adalah untuk mereduksi emisi tidak hanya karbon tapi juga SO2, serta juga kemampuannya yang sangat efisien dalam hal menangani limbah ya. Itu dua hal yang baru saya dengar dari Profesor Paulo. Nah, sebetulnya banyak bisa dilakukan oleh teknologi nano ini yang dikembangkan secara komprehensif di University di Brasil ini. Nah, tanpa berlama-lama lagi, kita dengarkan dan saksikan bersama insight dari Profesor Paulo ini, terutama peranan dari tentu nanoteknologi dalam industri nikel, di mana tempat saya bekerja, yang juga memiliki tantangan besar dalam menghasilkan emisi dan juga mengenangani limbah. Mari kita dengarkan dan saksikan sama-sama. Selamat menyaksikan.
And these things are about the size of a molecule or an atom. So nanotechnology is the ability to synthesize and produce very, very small things, like you get a meter and divide this meter by 1 billion, and then you have nanotechnology. Yes. So by using nanotechnology, we can produce new kinds of materials. And these materials can be very, very useful for many things in industry, like electronics, like waste management, for many, pharmacy industry, cosmetics and food industry, in many, many fields of applications. And actually we can produce very, very smart materials that can retain, remove, or transform air pollution and poison molecules into a new kind of molecules or different molecules, or remove these materials or these molecules from the environment. Yeah, for sure. Here in our labs, for example, we have the production of nanofibers, and these nanofibers can be used as a physical barrier for the transport of air, of pollutants in the air. So as the air passes through these barriers, the pollutants can be removed by these very, very small fibers. So it's a very, very kind of specific filtration, gas filtration, that can be applied, for example, for remove gases or toxic elements from the air. Yeah. Actually, by using some technologies, and many of them we develop here, we can remove the pollutants from the air. We can improve air quality. Also, we can remove pollutants from the water and the soil as well. And by this, we can retain these pollutants and transform these pollutants in another kind of materials. And these materials has no problem with not poison to the environment. So we can apply, for example, nanofibers and nanocatalysis for remove CO2 or SO2 from the environment. like 90% or more than 9%. Yeah. Nanotechnology is very, very efficient comparing to the usual approaches. That's because the nanoparticles and nanomaterials they have a very, very big surface area, and this very surface area compared to the volume and the weight or the mass is able to increase the efficiency. So by questions of, in the terms of surface area, low energies of interactions, and selectivity, we can increase the efficiency of many industrial processes. And for example, removing toxic. Yeah, for sure. Nanotechnology and especially nanoparticles can be used for safety. Actually, we are running some projects on this area, specific for CO, which is carbon monoxide sensors. It can be detected in the labor environment inside the laboratories in a easy and fast ways. Also, sulfide molecules can be detected in very fast way by using special kind of nanoparticles or even quantum dots, which we produce in our labs. Yeah. Actually, yes. By using nanotechnology, we have also some risks. Yeah, we can manage with risks inside the environmental place by managing or by doing new kinds of materials that are not toxic for people, for animals, and for environment. So we can use nanotechnology approach to produce no toxic and no contaminated materials for the environment. Oh yeah. Because when you remove, for example, CO2 from the environment, what do you do with this, right? Yeah. So by doing, for example, titanium nanoparticles or some similar nanoparticles, we can use photocatalysis or some light or energy produced particles for changing these molecules into a non-problematic molecule from CO2. Once you increase productivity, once you increase efficiency, this kind of approach could be very well welcomed to industries, and especially industries that work with nickel or heavy metals or detecting metals in the water, in the air, or some kind of this operation. When increasing efficiency, for sure it will be economical of the interest of economical activity. Yeah. We have at this university we have many running projects using nanotechnology and nanomaterials with some industries. As I said before, food industry, pharmaceuticals, cosmetics, or even steel industries can be used or benefited by this kind of approach. And at this laboratory, for example, we have some collaboration with the Army and the Marine for detection of poison gases in the laboratory facilities. Actually, if you use new nickel nanoparticles or new metal particles, for example, in batteries or new batteries, you can improve the battery life. You can improve the long-term life expectancy of batteries, and you can use this technology for researching new approaches of doing new batteries. Yes. This is a topic of the interest of many places around the world, and if you can change the production lines or not changing or adapt new approaches to the current production lines, for example, increasing efficiency and reducing the waste, reducing CO2 or reducing uh, carbon fingerprint in our process, we can also collaborate with the climate change or reduce the climate changes.